Welcome back to Daily Standup, the first one of the new year. So hope everyone had a good New Year's and looking forward to the new year. So we're going to start off by reporting on the progress of Prototype 2 backend data pipeline design. I'm actually going to talk about some issues that I encountered kind of during implementation, really, of this. So I saw this one relates more to my I found the problem when I was implementing my RabbitMQ message broker, and I had to refactor some stuff. But anyway, so the problem I was encountering is I think the image I was using of my specific RabbitMQ management, I think it was the wrong image, So I switched to use the Alpine management image, and it seems to work a little better. It was like my front-end application, which is the front end and then the back end, it would just appear blank. And I think it had to do with my Docker Compose file trying to start the front-end project before my RabbitMQ message broker was up and ready to use. And because I had dependency on that, obviously in the startup pipeline, but also on my home controller, I think it just put it in a weird state where it just kind of froze the front end from being returned, I think. Now, so what I actually had to do was I switched my image, but because I was kind of treating this as a prototype anyway, I actually went ahead and created a new solution and then more or less moved my front-end React project to that, and then I checked it into my source control, and then I started to do steps, and where it broke at the same time was when I added the image of the RabbitMQ management image in my Docker Compose file. And so there's something weird must be going on. And I looked it up, and it seems like other people were having issues with it as well. Like it was like when you added depends on RabbitMQ, it would just cause the Docker Compose to hang. And that's what mine was doing. And people said they got around that by using the specific Alpine version of the image. And that seemed to work for me. So that was kind of an interesting problem. I'm not confident that I actually figured it out fully, but I got it to work. So everything I think is back up to where I need it to be in order to get me to be able to continue on my prototype 2, right? So, or sorry, I think I might have been talking about the wrong ticket. Whoops. I meant to be talking about my prototype backend Q design number 1. So everything I just said applies to this ticket right here. That's my bad. So this one here, obviously, I just discussed the problems I was having. So I'm going to actually write a kind of a summary statement of what happened. So problem statement, ran into problem with specific RabbitMQ management image not starting correctly, causing the Docker Compose build to hang. And the solution, change to use Alpine. Alpine is, I'm going to have to look it up. I think I could be wrong. I think it's just a different, it might be a lighter weight RabbitMQ management. I don't know. I have no idea. I'm going to look that up later and see. So that's really the solution. That's the problem I ran into. And actually, I spent a couple hours on it probably today trying to get this to be in a good spot. But now everything is in a good spot. So I can just run my Docker Compose up and everything starts up. So now where that takes me, because now I've kind of added to this queue design, and I'm working out some problems and everything, and this is exactly what the prototype ticket is designed to do, is to bring out these problems ahead of time so you don't run into them when you're actually implementing this. And this is really where the power of prototyping and research tickets comes into play, is because something like this, you're not going to know that that's going to happen, right? Until you actually go to implement it, or, and by the time if you wait to implement this at the time of production, meaning like you have a story to create it and then to push it out to production and deploy it, and you run into this problem, it's gonna cause a delay inevitably, right? It's gonna cause a delay of a few hours, couple days even. I mean, I saw people on threads, going back and forth for days. For me, it took me a little over 4 or 5 hours. So for me, a day, right, over a day. So it took a while to figure out, right? And I think I just got lucky, to be honest with you, finding the right thread of somebody talking about this other image to use in the context of when using it inside Docker. So pretty neat. I don't know. I'm going to write up some more stuff on like an official document I have to help me keep track more or less of random issues like this. So that's one problem I ran into for the prototype, but I'm glad that I ran into it now, again, as opposed to later. So where that takes me is I'm actually going to create a new to-do task because I have something I need to do. This is going to be our API gateway, and we are using Oscillate API gateway. Okay, so basically what this is going to allow us to do is currently we have our front-end solution sending. So the flow currently is you open up, you go to the application, you're inside the React Native app, or you're inside the React application. If you make a request, it's gonna go to the back end. So for right now is the home controller. Right, I have it set up to be a basically an all-encompassing router. If you type in any route, it's going to try to take you to this home controller. Even if it doesn't register, if the front end doesn't have a route registered in Wouter, it's going to say, hey, we don't know what this is. Let's route it to the back end, and it'll work like that. What I need to do is, instead of always default routing to home controller, I want it to route to. I'm going to tell my front end to go to an API gateway, and the API gateway is going to route me to whatever microservice I need to. So I need to draw this up. I'm not good at talking about this without a diagram, but basically the flow is going to be this. So the flow is front end React project, and engine controller. So I'm going to be making a new controller to take care of specific endpoints for the engine. So and like there'll be a respective social controller, everything else, engine controller, and that's going to route me to API gateway, okay, and then that's going to take me to microservice. So why this is beneficial is because I can implement rate limiting, so throttling, so I don't spam a particular microservice a million times and cause it to go down, which happens to services out in production currently. Like that's when you hear like denial of service attack, with somebody's just spamming somebody with message after message and trying to get their system to crash. It's a legitimate security concern, so this is where an API gateway helps you to do that. It helps you to limit, say, hey, we're only going to allow 10,000 requests a minute or whatever it is. And anything beyond that is basically going to be held until that's freed. So why rate limiting, obviously security, benefits of that, single place to store routes to microservices, and then a big one, and this is a big one, is the front end has no knowledge of the microservices, right? And that's really the key to this whole thing. Obviously, the security concerns, the rate limiting are huge, and I need the rate limiting in my context, specifically for my engine's API that's going to be handling very, very high throughput of information. I need to limit that. And but specifically the last point is of the front end having no knowledge of the microservices. That's really what I'm trying to achieve, right? So the front end microservice, it doesn't matter what the back the back end microservices are. The front end shouldn't care what the routes are, shouldn't care about anything. It should just know that, hey, this is the route I'm sending it to, and that's all I need, and that's really all I need to know. So API gateways allow you to even extend, loosely coupling even more, because now you don't have a direct route to the microservice. You have now a direct route to your API gateway as opposed to all these different microservices. So the API gateway handles all the routing as opposed to, my front end application of doing that. This is going to take me closer to the end goal where I want to be, meaning I want to have a system where I can make a microservice in whatever language, whatever, and be able to consume messages from my front end and return a message back. And I can add in microservices, take them away, all without interrupting the front end at all. So that's where the message broker comes in with RabbitMQ. That's where the API gateway comes in. That's where Docker Compose comes in. So all these pieces are going to come together and create this really, really cool system that we're going to be able to see interact and see how the messages flow and see what happens in a failure, see everything like that. An API gateway also, a big one, is I think you can set it up to be to route you depending on if a service is live or it's not. Now, obviously, you might hear that in the context of a load balancer. And for my purposes, I could implement a load balancer, but I think honestly with Ocelot, I think I can get similar functionality. But again, we're going to research that. We're going to look into that. All I know is that I'm going to be adding a API gateway with Ocelot as its own standalone microservice that I can call from a front end. Beyond that, if I add a load balancer, so be it. That'll just be another layer after my API gateway, because I can say API gateway, route me to the load balancer, and then the load balancer will determine if I go to service A or service B, depending on how many requests are going to each. So we'll get there, but this is where we need to start for right now. So I'm confident that this is a good spot. So the what for this is create a new microservice to handle or to create new microservice for API gateway using Ocelot. Ocelot is just an open source one. It's really popular in .NET. I'm sure there's others, but we're going to use Ocelot. Create new microservice and add, this is the big one, add to Docker Compose file on front end. So obviously you can kind of get a feel for what's happening, right? So the Docker Compose file is in my front end application. The front end application's what you're accessing. That builds everything, that adds all the dependencies, and that stands up everything in its Docker Compose file that it needs to. So by us adding it there, and we're going to add a depends on to that, we're going to say, hey, when we start this application, the front end application, we're going to be starting the API gateway, the microservice, everything that it needs in there. Cool thing about that is once we register our images in the whatever registry we choose, you should theoretically be able to pull the front end project down and just run it, right? So that's what we need to continue adding that Docker Compose file for whatever microservices that we're adding to make this orchestration work. Create a microservice, add, and then I want to set up first route to my engine's API, and I want to set rate limiting. And that rate, I don't know what it's going to be yet. Obviously, I'm just testing locally on my computer, so the rate that my computer is going to be able to handle versus a larger instance instance size is going to be different. So we're going to have to, that number is just going to be a little bit of experimentation, but for right now, it's just going to be based on my machine, obviously, until I get further along in this project. But I think those are the 4 things that we need to do initially to create and add to Docker Compose. I guess I'll say create microservice and add Docker Compose. Okay, we'll go with that. This is a little bit bigger story for sure. So I am going to put this at a 5. You could argue that I could break this up, but again, it's just because it's just me. So I'm going to be doing this stuff anyway. If I was in a team setting, I might push to break this up into like 2 3-point tickets. Probably 1 to create just the shell, the new microservice, and then install Oscillate, and then that'll probably be the end of that ticket. And then the rest will probably be these bottom 3. Add to Docker Compose file in front end. That could be its own ticket, to be honest with you, because it's another area, another repository. So I could see that for sure. Actually, that might. Why don't we do that? I guess. Well, okay. Well, I'll put a caveat just because I don't want to split it just for myself. I think it's going to add just too much overhead for me. On a team, I would split this off into So what I'm saying is because it's it's in a different repository. I don't think that this ticket should be responsible for that. That's basically what I'm saying. So I think we got a good amount of work for this, and I think that's going to wrap up this stand-up, and I will see you on the next one.